So Jeff and I will present together. Okay. Is it okay now? Do you see
Beautiful.
everything? Okay.
But yes,
Yeah.
perfect. Thank you.
Okay now? Okay. So Jeff, you're here now too, right?
Yes.
Okay. So good afternoon, everyone. I think this is Jerry, and I currently with SJsU, San Jose State University. And this work, you look, there's so many names here, right? So what this imply? This imply we have been doing this for a while. We have been working on this for 2 years, try to create a Wildfire machine learning research, and then end up we are working on the machine learning platform to support the data, especially Wi-Fi data analysis and prediction. Okay, and so far I would say we did pretty good job in in most of the features, but we still work on the improvement of the reinforcement learning for file spreading. Okay, prediction. So all these students we listed here are our master student, okay, and some of as an undergrad student, they worked in several semesters on different master projects, and some of the student is work on the summer job, okay, just let you know. And here's our presentation highlight, okay, introduction, then we talk about Wi-Fi monitor analysis prediction solution problem, and we talk about existing survey, existing problem, existing research work. Then we start to talk about our system, especially we talk about our engineering process for data preparation, collection, and pre-processing. Plus, we also talk about how do we do risk analysis, prediction, and how do we do detection, and how do we do spreading predictions, okay? So this is a pretty big presentation, but I tried my best to work with Jeff together. But you probably know Wi-Fi has been a big problem in California, but also a big problem in other areas, such like in the Australia, in China, you know, several places all have the same problem. But California is a recently always have a hit by the Wi-Fi. Even this summer, you also start to see, but most people worry about this fall because of not too much rain, okay? Whenever you don't have too much rain, we have all the vegetation is dry, so you have a dangers here. So most of the problem we see is that we have a loss of property damage, and also we have a loss of some life, okay? Some people were dead because of that. The existing solution have several big issues. Otherwise, we don't need to do that, okay? First issue is the existing solution. Although we see several systems, even California's state government and local agency, they use some of the system, but most of the system is like a not global system. That's the problem, okay? And all the system maybe don't have a machine learning or don't have intelligence there. So they only can monitor what's going on, but they cannot tell you next 20 minutes, next 1 hour, where this file could be, okay? This gives them a lot of headache, okay? Plus the lot of dynamic here because of weather, you know, because the weather change a lot, and every year the rainfall also change a lot, and climate change cause another headache, okay? So currently in this presentation, we try to show you our proposed solution. And we have been work on try to have integrated system, adopt many existing the machine learning model, and using all kind of data together, try to provide a cloud-based solution, which the solution we expect should be replicable in any region you want. Okay, we hope like this. So this show you the top California top 20 Wi-Fi, okay? So in the past, you will see most of them caused by human, okay? And then some of them caused by lighting, okay? Some caused by power line. and some of them still don't know why. Okay, but anyway, these all has something related to human power line. Okay, so let's check. These the past. Recently we see how many Wi-Fi has happened, and every time you see recently have a lot of death toll. Okay, very high. 2018 you see property damage also very high, cost very high. Okay, so this causes a lot of problem here. Okay, so this show you what we want to give you. Okay, we currently use all kind of data together. Okay, all kind of data together. So that system will use weather data, satellite data, imaging, and remote sensing data, lighting data, power line data, fire history data. These are data together. So our goal is very clear. We want to use intelligent solutions, setting the platform, supporting our, the fire detection, fire alerting, and also fire risk prediction, plus fire spreading prediction. Okay, we want to achieve that. Okay, so here's an existing comparison. We show you what have been happened here. You look here, these are our student survey, study all the existing systems internationally. Okay, check what the system providing. You see many of them claim certain kind of prediction, but when you look at the data, they only have a certain kind of data, limited. Okay, some using sensor, only few of them using satellite, and many of them is a manual. Okay, and you will see some system, only very few systems using machine learning. Okay, and quite interesting, and many of them using other approach. Okay, other approach. So we did the survey extensively in these 2 years. We found a 3 different approach to, addressing the Wi-Fi issue. One way to do camera. So you put a camera on the mountain. They build a station there. They rely on the camera, or even human being look what's going on. Then they, based on the data they collect from camera, they want to have some alert. Okay, have some alert. The second approach is using sensor. Okay, so they put some sensor in different location, and then try to check if the sensor, sense the temperature high, or sense some water issue, or fire issue, maybe they will get an alert too. Okay, so but we originally tried that. And but later on, I found this is too costly. Okay, too costly, especially for Wi-Fi. For a small home, you can do that. Okay, but for Wi-Fi, it's impossible to do this. The third approach is a satellite based. So you're using camera on the satellite that they call imaging or satellite imaging, or they use a satellite remote sensing data. Okay, so either way will give you a large scale coverage, but also very effective to do the monitor. Okay. So we did a extensive paper survey, and have been submitted a couple of paper. We also accepted several paper, some including the journal paper too, talk about a Wi-Fi survey. We especially check, there are several, this slides actually show you all kind of data that have been used. Okay, some care about vegetation. Okay, some care about terrain data, because terrain data also affected the fire spreading. Okay, some only study the fire history, some using weather data, and so on. Okay, just show you. These other research has been published using machine learning approach. Like the UCI also did a very good job on the repository. But when you look at some approaches is index-based. If you check here, is index-based. So this idea is more like a statistic approach. Some formula. This is more historic and old-fashioned approach. Okay, and they based on several important parameters, then form a formula, then use the formula to calculate. Then they try to figure out whether there's a risk or not. Okay. The data perspective, you see they only use a certain kind of data and not too much other data together. So in our current study and even the machine learning platform, we target 2 different locations because anyway, we need to find a case to study, right? So we picked the one San Diego area, that's the southern, and also, we also picked the North California area, okay? Sonoma place, so we target these 2 areas. Then we're using our system to collect the right data to do the survey and to do research, and then we have a machine learning build up and integrate with system. Here's all the data we collected so far. We have a Wi-Fi history, we have a lighting, vegetation data, satellite imaging data, and also we have even have a drone data too, remote sensing, weather data, and power line. Okay. So here's some scope. The way we approach it is we look at it, the whole thing as a 3-dimension problem, okay? So we look at the whole Wi-Fi issue. So you have a you have a land on the land, you have a vegetation, you have a human, you have a transportation, you have a power line, everything, these are on the land, okay? Then you have something on the sky. So on the sky is a satellite, a remote sensing, those are on the sky, okay? Then another dimension we talked about is the weather situation. Like you have a weather data, could be wind, could be rainfall, could be sunny, and these are the different things. But when you look at it, we have looked at it several things. One is a risk prediction, one is a spreading prediction. These are 2 very important. For any one of them, we all rely on the fire detection. So you must need to monitor and fire detection. Then these 2 can be achieved when you have a good, solution. So here's our approach to do the data engineering. Okay, we try to show you. The first, we try to get Wi-Fi data history, of course, and these are data from California state, you can get it. And also there are some Earth data and satellite government data, you also can get it. For land cover, those including vegetation and also terrain data, we get from satellite information, okay? Then you have a weather data, we get from local weather station, or we also get from NOVA and other place. And for other data, we also get the other information together. I think this has some problem. But we get a satellite data. Here's weather data information. This show you all these weather station here on the map. Okay, and then you can see the detailed data we talk about. The dots here show you the station of a weather station. Okay. Then here's the power line samples, okay? And we get it from the energy website. These show you all the PG&E power line, okay? We can get them. And we also can do easy analysis. These are terrain data, show you different shapes on the landscape and topology. That'll give you an idea when you try to do widespreading, okay? And of course, you have a history data. That's California state. You have a website hosting these. You can get it from API, okay? We also have a satellite data used here, okay? So these are different kinds of satellite. The good news for satellite data is free, okay? That's a good news. The problem is each satellite only have a different duration, a different frequency. They probably have different resolution too. That's a problem. So in order to deal with the Wi-Fi situation, we really love to see the real-time, data, right? The problem is that currently only military people can use a real-time the satellite data. For us, we can get some close to real time. We call it discrete time, okay? So ghost station like a 16 or 17, these are really recently available. They're called geostation. And the good news for this kind of satellites are always in your sky, okay? They don't circulating. They always stay with you. You know, if you have a California, they will stay in the California. That's how it works. That's how it works. So because they have a lot of stations like that, so each location has one station target to it, okay? Good news is this, but however, the problem is their resolution may be not too high. They are 2 kilometer now, okay? And coverage, that's why. Every 5 minutes, that's a good enough for Wi-Fi risk prediction and Wi-Fi spreading prediction, okay? But there are other, the satellite here, MODIS, and also there's a NOVA, and then you have a European station, a set to Sentinel, and we have a landscape. Some of the stations are really useful for agriculture, but maybe it's not good for Wi-Fi because some of them is a daily, some of them is a 16 day, or 20 hours, okay? So we need to really figure out how to selecting those data carefully and use all the satellite available to provide integrated data set we want to do and serve our Wi-Fi prediction and risk prediction purpose, okay? This just show you for each station, each kind of satellite, where they stay and what kind of data they're getting it, okay? So here we show you the sample of a data set like a MODIS, GHOST 17, and Landsat 8. These each one we can use some band data to collect a certain kind of a data set, give you an idea what look like when you see a fire from the satellite in the sky, okay? But these are some comparison. If you want to find too much detail about where this particular brand used for, yeah, each band could be useful for a particular detection, and we later on we talked about, okay? So these give you another example of a contract, you see, and we have been using different tools to support us to improve our data, you know, especially increase the imaging contracts or enhance the resolution. On the top is the example of enhanced before, enhanced after. This is a color enhancement contracts. This is the resolution enhancement, okay, before, after, okay? So this is another example before, after, okay? You will see the difference, okay? Basically, this is a lot of data pre-processing needed. And ideally, when you get these data pre-processing, supposed to be for pre-training purpose. And after you've done that, you got a good resolution and good training, and then your machine learning becomes smarter. In the future, whenever you collect the data, we hope you can collect them at the same time. So now here I'll let Jeff, you want to explain that in detail?
Okay,
Yeah.
sure. So this is one of the criteria or the parameter that we can use for the remote sensing purposes. So on the lower right bottom over there, we can basically monitor the vegetation status. If it is healthy, still have a lot of moisture, you'll see over there the NDVI value will be 0.72. But when it is dry, then by using those two different bands that we have on showing on the top, near infrared minus the red wavelength, then we can find out that when the NDVI value is very low, then we are very susceptible basically to the fire situation. And on the, yes. So here is just showing that we have a web-based system that we can use to display or collect the data. On the left-hand side is we can collect the data from the Landsat satellite, and we can also support to customize the color, as you can see over there, so that we can see more clearly for which NDVI value. And on the right-hand side is from the MODIS satellite.
Yeah, these are two different kind of satellite. You can also pick and choose. Okay.
Yeah, so here is just to show that in the GIS, basically Geographical Information System, there are many projection systems. This is to show different projection system, what will be the impact in terms of the visualization. The most common is that we are probably accustomed is on the upper left over there. That's the most common projection that we are seeing. So here is to show the flow that we have to try to support, to deal with the such a large database. So we will typically do some clipping. Basically, in this particular case, we're showing that for the raster image is quite big, so it's really hard to work on. So we usually will clip it to the smaller size by first is adjusting the projection, as you can see over there. And then once it's matched with the projection of the smaller region that we have, then we can do the clipping. So this slide here is showing the NDVI that we just talked about. It's showing that the visualization of the NDVI value before and after the fire. Before the fire, you can see the more green over there, and then after the fire, then the color will change over there. So this is one of the area study that we have in the Southern California, close to the Riverside County. So on the upper left over there, that's a Landsat based on the infrared band, basically. And on the lower right over there, that's the NDVI value of each of the region. If you look at closer to that green box over there, it's basically when there's a fire which is occur around August, then yeah, the NDVI value will drop from the about 0.2 to close to 0.
Yeah. Anyway, NDVI is a one kind of index that's been heavily used for Wi-Fi detection. Okay, but data look like this. Is like a sensor structure data. Okay. Yeah. So now let's back to the data collection side. You want to continue, Jeff?
Yeah. So basically, on the collection, we will use the lightning data as shown over there, and then if we talk about the satellite data, and then historical data, and obviously weather data is very important. We will use that, and then also the vegetation and terrain, basically. So this slide here is showing one of the data analysis that we have done is the initial display here showing the statistic on the fire in the California, and then this one also be able to show us each fire in each year and how big those fire are, and we click it. If we click it, it will show the detail of the more information about it. So this is again our web base where we can check the weather. These are close to real time in terms of the weather. Basically, it's our hourly base in terms of the weather. We can select from over 300 stations in California. This is again our web-based system here. It's going to show that it's we are collecting from the Google satellite that has been mentioned before. Currently, it's showing the true color, basically the 3 band that we are accustomed to in terms of the visualization bands. So on this one, we are showing the false color here that is going basically using the infrared. Is going to give us better visibility about the fire location and yeah, where there is a fire. So this slide here illustrate the lightning that is on the right side here. This is actually from NOAA here. if we recall in the 2020, back in the August timeframe, basically throughout the 2-3 days, we are experiencing a lot of lightning. That's why then it start triggering a lot of fire, those big fire that is mentioned.
Yeah, lighting could cause not just power line fire, but also cause like a dry grass fire, especially in the night. Okay, so people say, why you worry about lighting? Depends on when this lighting happen. If you have a thunderstorm, lighting is okay because it's wet, right? You have big rain, no problem. But sometimes you have a lighting without any rain. That's the that's the dangerous problem. Okay. Yeah, keep going, Jeff.
Yeah, so this slide here, as shown previously, every 20 seconds, it's the lightning data will be collected by the satellite actually. So over here, what we are showing here that we can select within an hour or so collected the data and then display the image of any lightning. So as discussed before, these are showing the 2 possible sources in terms of for us to get the information about the power lines. One is California Energy Commission and the other one is from the Homeland Infrastructure Foundation. So this is to illustrate our flow, to try to, again, as mentioned before, that most of this GIS data is very big. We have to be able to deal with that. Our strategy is to try to do the clipping to work with a small region. So this is just showing the flow that on this large power line data set, then we have a flow to do the clipping to first to isolate the state, and then eventually going down to the county level.
Yeah, this will help us to do regional power line analysis detection for fires. Okay.
So these are the implementation that we put into our web-based system. So we can select the county, and then it will display 3 types of power line, basically. Yeah, so this slide is just showing some historical data analysis of the fire that happening in California. So on the, as we mentioned before, on the one of the parameter that we use is NDVI. There are other parameters also that is using similar to that is going to work better in the certain situation, like during nighttime or when there's a cloud. So these are there's other different parameter, which is the EFI and then NDWI.
Yeah, these are remote sensing data. You can use them. You can see the curve here, right? And sometimes they're pretty dry. Sometimes a lot of fire. You see the broken line. That indicates something going on there. Okay. So now let's check the fire risk. We also use the NDVI to do the fire risk index. That's one way to do. Okay. To check all the vegetation on the land, and every part. Every corner, you check what's going on. Then the good news is you can use this kind of NDVI to cover every pixel in the picture or on your land. See where they are based on the longitude latitude point. Okay. The problem is if you do for every inch land you do this, the computation very high. Okay. So this is the issue. That's here. We show you the NDVI here, the line curve, and also we did some processing. This is during fire and post the fire, and even before fire, you can check. So the data we prepared to do this help us to training. We actually intentionally selected different fire based on their time, based on their record. Then we target to particular land. We prepare our data to support our training. Okay. So this is another example here. You see, this is the vegetation from Landsat 8 data. and we check time series. Depends on, you can clearly see sometimes they move around, and from all this index, we actually did a compare together. For our machine learning model, one of the study actually use all three together to compare them. Then we can do some ensample, okay? And we can do some voting too, okay? So this is just one project example. I show you that this is the area we study. Our objectives every time the particular area you want to study, you can divide it to small cell. Then for each grid cell, we do detailed detection analysis. Then after that, we put together as a global or regional coverage, okay? So now let's start to talk about detailed solution for wildfire risk prediction. And that's one issue most people talk about. And this is the approach we use. We don't create our new model. However, we do ensample model based on existing model. Okay, so we have a different kind of data. Based on the data, we have a different set of a model here. So this is a risk. This is another risk. We have several model put together, random forest, XGB and SV, and this is the CNN together. Finally, we put a sample model to the voting, okay? This is another picture. You can see the idea. For each location, if you check, we divide it to small cell. For each cell, we check region by region, do like this. So here's a smoke related. This is a fire related, okay? So even based on the satellite imaging, based on the remote sensing, we also can see whether you have a smoke. So we create some smoke level, and also for fire, we have a fire severity level too. Based on that, you can show what's going on, okay? So this is actually already published. You can see online. This is one of the journal. Here we actually have two different, we took two different workflow together. So one is in sample only, the other one is a combined. So the only difference is the first one, in the left side, we put all the data together and feed everything to different model. Then we finally combine them to do the feature. Then we have a random forest to do the modeling and prediction. In the right side, it's kind of in sample, okay? So you do NDVI, and meanwhile, you do other kind of data, like weather data, Powerline, and terrain data. We put together and feed into the selection, and we do feature analysis. And then we do, you can see the data is divided, okay, intentionally. Then we have a feature collection. And so interesting is two different places. We both have a random forest model applied. This is a classified model. Random forest is another one. But the difference is this only cares this kind of data. This only cares this kind of data. Then we combine and to check the ensample, okay? So our result turns out pretty good, okay? And so we find achieve 90 something, okay? 90 something accuracy. So, okay, just let you know. Now let's move to detection. You probably say, detection, actually, everybody think is easy. The reason is you can go to satellite monitor, see it. The problem, you cannot always rely on person to look at a screen, right? So ideally, you still need a detection model and to help you automatically give you the alert if something going wrong, okay? And so that's why this is still needed, okay? This show you the North California area. We're using MODIS to show, okay, the detection. And here's another example. Jeff, you want to expand that diagram?
Yeah. So this is one of the primary source that we're using for the fire detection. So she's showing the MODIS satellite. The left side over there, you are showing our visual band. Basically, on the right side, you can see it's the same image, but when we use the infrared bands, you can see clearly now the location of the fire. So basically, for the detection, we'll be using the band 721 here for the MODIS because it gives us better visibility.
Yeah, there's a lot of tricks when you apply these satellite data to help you to solve some problem. Okay, keep going. Mhm.
Yeah, so this one showing the in the Southern California on this MODIS data. So the MODIS data is we have to work in this high resolution. So that's one of the challenge. Now we don't want to downsize this because when we downsize this for training, then it's the result will not be good. As you can see over there, the image, the object is very small, basically. So we preserve the high resolution of that, and the strategy is to slice this into the smaller chunk and then work with that, basically, for the training and then for the detection.
Yeah, this way we can speed up our process and make things everything easier. Okay.
Yeah, so this slide here showing some of the training process of that we are doing. So it's showing the labeling of these slice high resolution images, basically. And this is one of the interesting thing on over here is we also want to not detect to do the false detection. Basically, on the top over there, you're seeing that it's sort of have some kind of a shining thing, but it's not a fire over there. That one is a solar farm. So we train our machine learning also not to get flagged by this false visual here.
So these detection model, we got a pretty good result too. Okay, just let you know. And here's the detection training we already talked about, right?
Mm-hmm. Yeah, so it's a little bit hard to see, but it's this is the time is to show that.
Small one. You see the small piece here? Yeah. Okay. This is a label part.
Yeah, so on the implementation on the machine learning side of the fire detection here, we basically divide it into two portions to support later on in the actual production that will be able to scale up. So basically on the interface, or is on the left side over there, but on the right side is that's where the machine learning model is being deployed. So the machine learning model is in the separate instances where, if necessary to support the maximum performance, then we can duplicate these so that we can accelerate the detection. Yeah, so this is just an integration to our website here.
Yeah, this shows you the detection part. Okay.
Yes.
So all the screen have an animation, whatever. This is not really animation. This is our system, recording. Yeah. So now these show you the detection concept, how we do it. We actually deploy all these index model, we put together, and we extract it, implement, and do the training. So this is before and after. We also check whether it's a burning area or not burning area. So before and after fire, so they are indexes will be different. So we actually check that, make sure we don't have a false alarm. Okay. So this also detection the way we do. Okay. So we're using remote sensing data to do that job. And then we can double check whether it's a fire or not fire using a random forest. Okay, to show you. Now let's talk about widespreading prediction. This is the last subject. Okay, I know some people maybe think that we got too long here. So here we show you the model we apply for spreading. We actually apply two-level spreading here. Okay, one is you already see for each small cell, first big area we want to control, right? For each small cell, we divide to a lot of small cells. For each great cell, we apply this model, put this way, okay? Then we do the Q-learning and value iteration. These are reinforcement model we apply. We actually apply several reinforcement learning model here, okay? We also do the fast alert. This is a fast RCN, do the detection. And we want to use detection to check and then to do prediction. Okay, so here show you the basic idea. How do we deploy the reinforcement learning here? For each location, you see that? Anytime you have 5, it could be all different directions you can go. But when you go, depends on the weather, depends on wind, and also depends on terrain and vegetation, okay? So that's why we treated this as a stay. And the whole reinforcement learning idea is based on the agent. And you can consider agent is the person want to put a fire, and now you face the fire, and then you want to see what's going on, right? So you have a condition, that's a state. Then you have a rewarding. So the whole reinforcement learning basic idea is try to learning the optimization rewarding policy. Make sure every time you did good job to rewarding your machine learning model. So he will make a good prediction or correct the prediction. Here's a data set we use, weather data. It come from NOAA usually, and these are data parameter we choose. And with status here, they talk about, all kind of status here. We classify them. We have a slope, and all these are landscape related, okay? Then we have a few talk about vegetation, how dry it is, and also whether there's a moisture and so on. These all could be done by MODIS satellite data using NDVI, okay? Those data, we don't need a real time because this could be before, maybe 1 day or 2 days before, you already checked that because MODIS give you daily results, so you can do this easily. Burning status, that's the real thing we want to find out. And also this also don't need a real time because already burned. Unless during the fire, you want to check what's going on, okay? So here I show you the example. So we actually applied our revolt policy here. We come out of this kind of policy, okay? There's a little bit detail. We don't want to spend too much time here, but just let you know, if there's a fire, we give a 1. If no fire, we give a 0. If I really have we give a wrong or no fire, we get -1. But anytime we got a wrong, we got a penalty. So we have a -1. Okay, we got a correct, we got a +1. Do like this. Okay, here just show you what we do typically. Okay, so this is the model. This is one of the model here. Okay, so model, machine learning model, you have a policy here. Then you have this kind of, for each cell, we do that kind of stuff. Then we decide where to go. Okay, where to go. So this show you animation, show you example. Okay, for every day, what's going on, right? You say false, negative, or positive or negative. They show you what happened. See, the left side diagram show you the ground truth. The right side diagram show you our prediction. Okay, of course, our prediction so far is not perfect yet. Okay, still has some room to improve. But for me, I think here show you a comparison. Okay, we got only certain reinforcement learning part we still need to improve. Just let you know. The other rest of part we did a good job. Okay, so here's final slides. I want to show you. This is our design for the machine learning model we have for the platform. So we have a lot of data-oriented stuff. We have a dashboard. Then we have a 3-piece engine, and then we have a data collection here. Okay, so these are data collection, data management. And then later on, we're adding evaluator. Currently, we haven't added on it. So these things we already have. This is a still improvement. Okay, so I will stop here. And thank you, Ron.
And have you published, are you going to publish this as a paper?
Yeah, we already published 3 papers now, and 2 of them also, another 2 in pipeline. This one, okay. Jeff spent a lot of time, so that's why I give him credit. Also encourage him to come to present with me. Currently, he's our thesis student. He planned to graduate in the 4th semester. So,
great.
Of course, of course, the next few months, his job is writing paper and put together. Okay.
Okay, great.
We plan to commercialize that, put this way.
Okay, I have a question. Actually, I have a question. How difficult was it for you to get the data?
Currently, Jeff, you can add on later. Okay, so currently what they do is we spend a lot of time. That's why we go through a lot of project group, right? So each project group, we find certain kind of data, then we find the right data source. then most data here is API driven data. So we don't need to invent our own data. The only thing we need to make sure is that we need to have a proper training data to support our model development.
I see.
The raw data is everything is from government. Okay.
So
Government
this is
website,
publicly available
yeah,
data. This is
yeah,
all
government
publicly
website. Yeah,
Okay.
yeah, not published. It's a public data. Yeah.
public
that's,
data.
yeah, that's a good news.
Okay,
So I'm
great.
also thinking about in the next year, if we have a chance, I will encourage a big data conference, maybe set up some kind of a big data cut challenge for students to do some kind of data, because NASA got so many data, not many people use them. Okay. So I think that would be a very good scientific research data source. Okay.
Is it like a hackathon? Is it like a hackathon?
Yeah, yeah, I'm thinking about that way. This time we did good job for autonomous car testing, right? So I believe now it's time we need to think about a big data area. We need to have something interesting, okay?
Because this is a very important problem. This wildfire prediction is a very important problem, and
Yeah.
California, I think this is very timely and very important.
Yes, we visit California State one time, okay? But you know government, right? Government is a government way to do it. You say, okay, when you've done something, show us. That's all. Now I need to show to them, okay? Okay, we have a hands up. You can just unmute your mic and talk.
Hello, Professor. Good evening.
Yes.
So you said that there's a delay with the live data, with the satellite data. But
Yeah.
so in order to detect progression so that we'll be able to warn people about the incoming fire, something like that. So
You're talking about what delay? You're talking about lighting data time?
I mean,
Or you're
getting
talking about the Wi-Fi?
how soon will the fire reach me? So if I'm like 30 minutes away from the fire and the fire
Okay.
is coming in my direction.
Yes.
Yeah, so to get that kind of warning, so without live data, how are we mitigating that?
Yeah, of course you need a light data. We are not talking about fake data here. All the data we use is a government data. Understand?
Time delay, there'll be a
Public
time
data.
delay, right?
The only difference is how frequently the data give you. Are you real-time data? Are you discrete time data? Currently, some of the data, you see, for vegetation, for terrain, these analysts, we don't need a real-time data. We can do it. Okay? But for some of the data, like fire detection, then we need a really the weather data. We hope have a close real-time data. Then we can make a right prediction. Make sense?
Yes, Professor.
Clear now?
I mean,
Yeah,
I'm asking, is there a way to
maybe I
delay?
can add here. Sorry,
Okay, Jeff,
maybe I
talk,
can
okay.
add here.
Yeah.
I think it's so I think as shown before in terms of the satellite data that we use, there are two newer satellites that is actually can give us the data point every 5 minutes. And this data is actually available at the AWS, at the Amazon, and the Google. So we can retrieve that to support the near real-time detection, basically.
Yeah, Jeff talked about a ghost station where I talk
Ghost,
about
yeah, ghost satellite, yeah.
17. Those two satellites always in our sky under California. They don't move around. Okay, so that's called geostation data. So those data useful is every 5 minutes they give you, and also give you the good resolution. They give you 2 kilometer resolution, but now we are trying to mix the training together with the other satellite data together, so we can improve our the recognition. Make sense? So
Yes, Professor. Thank you.
that answer your question?
Yes, Professor.
Okay, yeah, but this is still have a lot of research you need to do. Okay, I'm now trying to say we're already done. Okay, that's why I invite some student here to check. There's there's more room to be going. Okay, I talked to NASA before. They say only military people can do the real-time data. Okay, for public, no, you cannot get a 5 minutes would be good enough. But for Wi-Fi prediction, 5 minutes is good. Okay, so every 5 minutes, if you say after 5 minutes, you can tell me, next 30 minutes where this fighter go. Then firefighter will be very pleased. Okay, they can evacuate those people. Make sense?
Yes, Professor. Thank you.
Good. Okay.
Okay, Jerry, thank you for your presentation. And this is your certificate. I will mail it to you.
So
Sir,
actually, this one is supposed to be Jeff, okay? I don't need that. I just let you
Okay.
know. Already talked to student, prepare that, okay?
Okay.
So Jeff
Thank
will
you.
have a one invited talk certificate, okay?
Okay.
So
Thank
I
you.
want to show student, if you do good job, we provide platform for you, okay? That's why. Thank you, appreciate it, yeah. Yeah, already have a timeout, right? Is that?
Yes.
Yes, we are already a couple of minutes past, but that's okay
Okay.
because the next session starts on the hour.
Okay, so Peter, you have a question? I know you have just land a new position, right, in the UK. Yeah.
Yes, I am. As a matter of fact, I do have a question, if you don't mind my asking.
No.
I was wondering, are there any collaboration with universities in China with respect to your work?
Currently, no. For Wi-Fi, this is very sensitive. So, of course, some people ask me. So I did not respond that. That's why this one is a purely SJsU made. Okay, put this way.
No, okay, that's completely fine. But I'm hoping perhaps in the future, when I heard the word hackathon mentioned previously, I thought that would be a fantastic opportunity for our students as well to get into the field and explore it.
Exactly. I'm thinking about even in the future, I can do hackathon using our platform. So we can say, oh, you can pick your area and then you collect your data and do that for us. Then we do that for you, your own, right? Then we create your new machine learning model because I believe this is the only difference. Wi-Fi, every area, their landscape is different. Their vegetation is different. Their terrain is different. So their weather is different. Therefore, their Wi-Fi prediction model and should be different. Make sense? You cannot just say, oh, I have a model here. I can just use it for other place. Not work, okay? Not work. Because everything, condition is different. Make sense? The other research direction could go is currently we assume is a one agent here, but it's not true because in the one Wi-Fi situation, maybe you got the one file source first, and then suddenly becomes several places of file, right? So then for each place, that's called multi-agent, right? Multi-token here. Currently, we just assume one token, okay? One token move around, you see? So, but if you have a multiple file source, they move around, could be different. Make sense? So that's another huge research could be. The other place we can go for research is you could go for distribute the machine learning model. Currently, we are not distributing machine learning. I plan to do next, okay? In case you guys are interested to collaborate, let me know, okay? Make sense?
No, that's a fantastic opportunity. As a matter of fact, I noticed today we had an international audience. So it would be great if we were able to recruit master students, for example, from Sweden and the UK and different places around the world. And it would be interesting to see how it works on different geographical locations.
Yeah. You even can compare them, right? You can compare them. What's the cost? What's the difference? What's the file behavior? What's the spreading behavior? Make sense? I also have one group just finished the project last semester. They studied the Wi-Fi impact to the air quality. Okay, they already just finished it. We're currently in the writing paper stage. So we find out even you have a different place have a Wi-Fi, but the neighbor have affected severely in the air quality problem. But the question is, you need to let audience, public know how severe it is, right? You probably know last year, we cannot even get out, say, okay, everybody stay home. The fire is, the weather and the air is pretty bad, Yeah, okay, yes.
No, that makes a lot of sense. Thank you so much for your contribution.
Thank you. Yeah, we hope we can show state governments, we currently got something. Okay, thank you. I think
Not a problem.
Any question from student? We have a lot of people here, right? So any idea? Any question? Maybe I know I invited some students because they are look for the new master project, right? So they probably can look around, find out what's going on, right? Make sense? Yeah. And next, by the way, tomorrow I invited one of the group. They did a Wi-Fi drone. Okay, that's also a very exciting presentation. I suggest you guys attend it. That's also our master project presentation, but they did an excellent job. That's why it turns out that one of the UAV speaker cannot show up. So I say, okay, so we invite this group to give a better presentation. Okay, yeah. Let's talk about how to use. Yeah, let's talk about how to using drone to get a machine learning model to help them to chasing the fire and also to monitor the fire, reporting the fire. That's what the drone doing. Make sense?
It sounds very exciting and very promising. Definitely.
Yes, you will happen. Okay, thank you.